Hi, I am Josua, and in this first video we will talk about machine learning. We will try to acquire a practical sense and intuition of machine learning. You will encounter different definitions of machine learning given by different authors. I will not repeat this definition in this video, but for me, machine learning essentially consists in determining the parameter of mathematical models. What do we mean by mathematical model? Well, a model is a mathematical representation of a phenomenon. It's a simplification of reality, it's an abstraction. For example, we all have this intuition that when we push an object, the object moves, and that the more massive the object, the more difficult it is to move. A little more formally, we can say that when a force is applied to an object, the object is accelerated, and that the more massive the object, the more difficult it is to accelerate. This is the intuition that Sir Isaac Newton modeled, meaning he created a mathematical representation for this phenomenon, in that we know today as the fundamental principle of dynamics, and which is expressed as follows: the sum of the forces equals the mass of the object multiplied by its acceleration. In machine learning, what we are modeling are the relationships that exist in our data set. By just saying that, we can see that machine learning requires at least two hypotheses. The first one is the assumption that there actually exist relationships, correlation in our data set, and the second one is done by choosing a mathematical representation for these relationships. More concretely, let's imagine that our data has a property, let's call it E2, that is proportional to another property, let's call it E1. We can represent this relationship of proportionality as follows, where beta is our parameter. If we determined beta, then, given any value, for example A2, that we're supposed to share the relationships that exist on our dataset, we could determine the corresponding value A1 by this relationship of proportionality. Even more concretely, let's suppose that a person's weight is roughly proportional to his height. It's not correct, but it will do it for our example. In this case, we could build a software that would predict, given a person's height, his weight. To do so, it would be necessary to determine the beta parameter that corresponds to this relationship of proportionality. Right now, you are probably wondering, how is this beta parameter determined? Well, this is exactly the role of machine learning, to automatically determine the parameters of our models. In the real world, models can be quite complicated, and machine learning will try to automatically determine their parameters, as we said, but it will also try to minimize the error made by our models on the training data we are presented with, and automatically select among possible representation the best fitting one for our problem. So, we can notice that machine learning is more about automatically determining the parameters of mathematical models rather than the fantasized idea that we may have of machine learning from a book, for example. When we talked about our intuition of models, we were talking about phenomena. And later on, we are more talking about data. So, what is the link between these two notions? Well, whether we are modeling the behaviors of customers on a website or the behavior of a rigid body, its motion, we are actually modeling phenomena. But to do so, we make measurements, we collect data, and later on, it's on these data that we will rely to determine the parameters of our models. Generally, later on, we will just talk about this data instead of the phenomena themselves. In practice, under the hood, a learning algorithm will generally solve an optimization problem. Here, optimize means to minimize or to maximize something. To understand why, let's consider how we could determine the parameters of a model based on available data. To do so, we will try to minimize the error made by our model on the training data it is presented with, or we will try to maximize its gain toward a goal defined in advance. We will call Cost function, a function that assesses the level of divergence of our model compared to the expected results, and a gain function, the level of success of our model toward a goal set in advance. This intuition that we just built can be discussed. Indeed, there exist non-parametric models for which the number of parameters grows with the number of data in our dataset, and instance-based models which has no explicit mathematical representation of a phenomenon. However, in my opinion, machine learning continues to do, even in these cases, the same thing, determining the parameter of mathematical models, even if the number of parameters of our models grows with the number of elements in our dataset, or even if the mathematical representation is not explicitly known. Thank you for watching this video. I hope it allowed you to acquire a little intuition of machine learning. For more details, for more explanations, you can go to my blog, of which I put a link in the description. Thanks again and see you soon. Don't forget to put a like if you enjoyed and to subscribe. See you soon.
Dancing in the dark with you.